Hello, I'm Sonic. This is the final part. As this question we have left off. What happens if we integrate the already used values? But this cannot be defined anymore. We use a new trick called integration by parts. In general, we write f of x times g of x dx is equal to f of x times integral g of x dx minus entire integral dx containing derivative f of x and integral g of x dx. For example, is it possible to use integral log x? Probably not. We need to separate into two parts, 1, and log x. Then log x is taken out from the integral, then only integrate the appropriate values minus integrate the rest of these. Then x times log x minus integral dx. Therefore the answer becomes x log x minus x plus c. Another example, let's take any one inverse trigonometric function. Integral of inverse sine x dx. Using by parts, integral sine inverse x is equal to x times inverse sine x minus integral x by square root 1 minus x squared and dx. If you take 1 minus x squared as t, then dt by dx is minus 2x. When you solve this, we get x times inverse sine x plus square root 1 minus x squared, plus c. Kinda tricky, isn't it? You can find the rest of these used values through the web. So you now know how to integrate these appropriate values. Like, comment, and subscribe now in YouTube.